In this unit, we're going to be looking at systems of equations. There's 3 different ways that you can solve systems. We're going to start off with solving equations using substitution. This is more the algebraic way. So this is a lot of based off of chapter 1. So, as you guessed it, substitution is a method that is useful when one equation has already been solved for one of the variables. There's different ways that you can solve this as far as what you're given. But when you solve it, you could have a 1 solution, a no solution, or an infinite solution. If you get a 1 solution, you will have x equals a number and y equals a number. When you get a no solution, you'll end up with something like 0 equals 6, and an infinite solution, you will have something that equals 0 equals 0. And we'll talk more about that when that actually happens. So for our first example, your goal is to get a variable by itself. So looking at this, we have x by itself. So let's read kind of your steps. So get one variable alone. Step 2 is sub equation into second equation. Step 3, solve for the variable. Step 4, solve for other variable. Okay, so I know you're writing these steps down and you're like, okay, this doesn't make sense. You're right, it doesn't, because we haven't done an example. Once we go through the example, it'll make a little bit more sense. So first off with this one, our goal is to get the variable alone. We already have that. This x variable is alone. So I'm going to take this x and I'm going to sub it into the second equation in place of that x. Okay, so again, it might be useful to use highlighters. So when I replace it, I now have 2 parentheses minus y equals 53. So similar to when we were evaluating equations, if we had x equals a number, we would take that number and sub it into the equation and solve. It's the same concept, we just have a little bit more to it. So we're going to opt this out for 4y plus 16. Okay, so now I only have a y variable in there, so I'm going to go through and just solve for y like I normally would, just like a regular equation. So I have 8y plus 32 minus y equals 53. Combine my y's together because they're like terms. So I have 7y plus 32 equals 53. I'm going to subtract the 32. 7y equals 21. And then divide by 7. Y equals 3. So I've completed step 1 and step 2 and step 3. Now I need to solve for the other variable. So I solve for the other variable by subbing into one of the original equations. I'm going to sub into, we'll call this equation B and equation A. It's going to be easier to sub into equation A. So I've got x equals 4 times 3 plus 16. So this 3 went in here. Now I just need to calculate that. X equals 12 plus 16. And I get 28. There's my solution. So again, just going back through this. Since we started off, equation A was an x equals, I didn't have to get the variable alone. So I could move on to step 2. So I subbed that equation that I highlighted in yellow into my second equation. when I subbed it in, notice I put parentheses just like we do when we evaluate when x is just a number. I went through and I solved algebraically for the variable in step 3. Once I got that variable solved, I subbed it into the original equation to solve for the other variable. That's step 4. So now let's look at example 2. On example 2, I don't have an equation where the variable's alone, so I have to do that first. Looking at all of my options, if I look at equation A, the x and the y both have a number, so those aren't ideal ones to solve for. But if I look at equation B, x is alone as far as the only thing attached to it is the 4y. There's not a number in front of the 1. There's not a coefficient there. That's going to be the easiest one to solve for. So I'm going to move that 4y over. I now have x equals 7 plus 4y. There's my step 1. Get one variable alone. Check. Now, I'm going to sub into the other equation. In this case, I have x alone, so I'm subbing into the x spot. So I have 2 parentheses plus 3y equals 3. I'm going to go through and solve for the variable on step 3. I distribute. So I have 14 plus 8y plus 3y equals 3. Combine my like terms, they're on the same side of my equation. So I have 11y plus 14 equals 3 minus the 14. 11y equals negative 11. Divide by 11, y equals negative 1. Step 3 is complete. Now I need to solve for the other variable. I'm going to plug it into my original, or I can sub it into the one that I got alone. That one's going to be easier. So I have x equals 7 plus 4 times negative 1. X equals 3. Now, what you can do is you could check and see if your solution's correct. You could take your x and y and plug it into both equation A and equation B and make sure that it works out. If it doesn't, then you know that you've done something wrong. So we have one more example to get through. Now on this one, we're supposed to get a variable alone. I can, but notice on this equation, on equation A here, there's no y. So this one I actually am going to just solve for x right away. This one actually is an easier process. X equals 6 right away, and then I can sub it into my x variable over here and just solve. So 6 minus 5y equals negative 29. Negative 5y equals negative 35. Y equals 7. I know I didn't have in the notes here an example of a no solution or an infinite solution, but we will talk about that together when I'm actually in class, so we can go back through this and look through and make sure that we're understanding our substitution process. So again, follow your steps. Get one variable alone, sub-equation into the second equation, solve for the variable, and then take that variable that you solve for and sub it into one of your originals to solve for the second variable. I'm sorry that I have a cold and my voice is a little cracky today, but hopefully that should help you with your substitution.